This is Algebra 1, Lesson 9.1. We're going to look at identifying quadratic functions. So Chapter 9 is pretty much dealing with quadratic functions. So let's go ahead and take a look at our warm-up first. Okay, so this first one says to evaluate x squared plus 5x when x is 4 and when x is negative 3. So our first step is going to be to plug in x equals 4. So let's plug in x equals 4. So that means we're going to put 4 squared plus 5 times 4. We're just plugging it in right into here. So 4 squared is 16, plus 5 times 4 is 20. So 16 plus 20 is 36. Okay, if I plug negative 3 in, here's where you guys really have to be careful. You need to put negative 3 in parentheses because we're going to square negative 3. If you don't put the negative out inside the parentheses and you just wrote like this, that answer is actually just negative 9. But we want to square, let me finish writing that. We want to square the negative 3, so we have negative 3 times negative 3, which equals 9. And then 5 times negative 3 is minus 15. So then we would get, what did I have before? I think I did something wrong earlier on my own notes, not you guys's. So we would have negative, if I could subtract 9 from 15, I would have negative 6. Okay? All right. So the next part says to generate ordered pairs for the function. So basically it means we're given these domain values, negative 2, negative 1, 0, 1, and 2. And if you guys remember, domain, all that means are those are your x values. And we're going to plug those in for x and see what we get for y. So if we plug negative 2 into x here, negative 2 squared is 4 plus 2 equals 6. If I plug negative 1 in, negative 1 squared is positive 1, and then I have to add that 2, so that's 3. If I plug 0 into x squared, that's 0, plus 2 is 2. If I plug 1 into x, I get 1 squared, which is 1, plus 2 equals 3. And then if I plug 2 in, 2 squared is 4, plus 2 is 6. Okay? Excuse my cold. So we're going to identify quadratic functions and determine whether they have a minimum or maximum. We're going to look at what those words mean today. And then graphing a quadratic function if we're given its domain and range. So you're going to hear the words quadratic function, parabola, vertex, minimum, and maximum. Those are the words you're going to hear today. So if you look at the function y equals x squared, it's shown in the graph down here, okay? Notice that this graph is not linear. Remember, linear means we would have a straight line, and this function is not linear. It is a quadratic function, and a quadratic function is any function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are just numbers, okay? But a can never equal 0, okay? So because if you have a 0 here, then you would have no term here. So you always have to have an a value that is not 0. The function y equals x squared can be written as y equals 1x squared plus 0x plus 0 because there's no b and c terms. So that's why there's nothing after it. It's still a quadratic though because your a value out in front of the x squared is 1. So as long as you've got an x squared, you're good to go. So if you look down here, y equals x squared, here's the function when it's graphed. In lesson 5.1, we identified linear functions by finding that a constant change in x corresponds to a constant change in y. So the differences between y values for a constant change in x values are called the first differences. So you guys might remember this back in chapter 5, we looked at if I went from one x value to the next x value, as long as that change was the same for the x values and for the y values, then it was a linear function. And so that first change from the x and y values, or for the y values, are called your first differences. If you look at the differences between those changes, so once you found the first changes from those ones, if you look at that, the next ones, those are called the second differences, and those are going to be really important for quadratics. Notice that the quadratic function y equals x squared does not have a constant first difference. So if you guys look down here, there's not a constant first difference, but its second differences are constant. And that is true for all quadratic functions. So the second difference has to be constant. We also have to make sure that the x values are constant, okay? So the first differences of the x values have to be constant, but we need the second differences of those y values to be constant. So let's decide if this is a quadratic function. So if I go from -2 to -1, hold on. Okay, so we're going to look and see if this is a quadratic function. So we need to check if the differences in our x's is the same. So if we go from -2 to -1, that is adding 1. If I go from -1 to 0, that's adding 1. If I go from 0 to 1, that's adding 1. And if I go from 1 to 2, that's adding 1. So all my x's have a constant change, so we're good there. Now we're going to look at the first differences of my y's. If I go from -9 to -2, that's adding 7. If I go from -2 to -1, that's adding 1. From -1 to 0, adding 1. And from 0 to 7 is adding 7. So the first differences aren't the same. That's okay. It's the second differences we're going to look at. So now if I go from 7 to 1, I'm subtracting 6. If I go from 1 to 1, I'm adding 0. And if I go from 1 to 7, I'm adding 6. So if I look at these second differences, are they the same? They are not. So this is not a quadratic function. Quadratic function. Because the second differences are not constant. I'm going to abbreviate this. Are not constant. So even though those x values over here were constant, these were not, okay? Just be sure that the x values are constant. So if you check and the x values back here, if we had checked these and they weren't constant, there's no point in checking the first and second differences of the y. So this has to be constant in order to go on. So make sure you pay attention to that. Okay. Now we're going to identify if this is a quadratic function. So in order to do that, we want to see if it is in the form ax squared plus bx plus c. Well, if you notice, if I wrote this with my x squared, my a value is 0. There is no a value. There's no x squared value, so this is not a quadratic function. Because a is equal to 0. So if there is no a value, okay, meaning it's 0, it doesn't exist, there's no x squared term in here, then it is not a quadratic function. For this next one, we want to see if it's a quadratic function. So I want to move everything to one side. So I have a y equals. So I'm going to move this 10x squared over. So I have y equals 10x squared plus 9. So is this a quadratic function? It is, because my a is 10. I don't have a b term, meaning something before the x, so that's 0, and my c term is 9. It's okay to have a b or c term that is 0. You cannot have an a term that is 0. So as long as we've got this x squared term, then it is a quadratic function. So this kind of explains you can only have a not equal to 0. It's okay if your b and c terms are 0, meaning there's no terms there. Okay, so now we're going to look at a graph of a quadratic function. And this graph, actually, it's called a parabola. So to graph a quadratic function, what we need to do is we need to come up with enough points, or ordered pairs, that's another word for points, to see the shape of the parabola, and then we connect the points with a curve. So we're going to look at that next. Okay, so we want to use a table to come up with points to graph. So we have a quadratic equation here, y equals 1/3 x squared. So we've got an x squared, so we're good to go. and they're giving us x values that we're going to plug in and find the y values for. So I went through, and if I plug in -2, so if I plug -2 into there, that becomes 1/3 times 4, because -2 squared is 4, so it's 4/3. So when x is -2, y is 4/3. If you plug -1 in, you'll get 1. If you plug 0 in, you'll get 0. If you plug +1 in, you'll get 1 for y. And if you plug 2 in, you'll get 4, or 4/3. So make sure if you don't understand how that happens, that you go back and check that. So basically, you're just plugging these into x. So our points are -2, 4/3, then -1, 1, then 0, 0, then 1, 1, and 2, 4/3. So on the next page, those are plotted for you. So we had the point 0, 0, -1, 1, 4/3, and 4/3. So if we went over -2 and up 4/3, there's a point there. If we go over -1 and up 1, there's a point there. If we go over 0, 0, actually I lied, guys. This should have been 1/3. I'm sorry. If you plug -1 into there and square it, you get 1/3 times 1. Sorry, I was jumping ahead of myself. So make sure that these are 1/3. Forgive me. 1/3 on that other page. 1/3. Okay, so my other point, 0, 0, is right here. If I go over 1 and up 1/3, there's my other point, and over 2 and up 4/3 is my other point. And then it's just a smooth curve. I know that didn't look very smooth. That's a smooth curve to connect the points. So here's another function, y equals -4x squared. So we're going to plug in some values, so -2, -1, all of this. So I already went ahead and calculated these. Just be careful that you guys are plugging in the negative values, and when you square it, for example, if I plug in -2 into x, it has to be in parentheses, because when you square -2, that becomes a +4. So I get -16. If I plug in -1, I get -4. 0 is 0. If I plug in 1, I get -4. And if I plug in 2, I get -16. So I'm going to draw a graph over here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if I go, I know that I've got the point 0, 0 right there. If I go over -2, I go down 16. And if I go over 2, it's also down 16. And then -1 is down -4. 1, 2, 3, 4. Over 1, +4. So my smooth curve should look something like that. It's a long, skinny parabola. That should have hit those points. As shown in the graphs in those other two examples, some parabolas open up and some open down. So back here, this one opened down, this one opened up. Notice that the only difference between the two equations in the value is the value of a. So when a quadratic function is written in the form y equals ax squared plus bx plus c, the value of a determines the direction it opens. So basically, if it's a -a, the parabola opens downward. And if it's a positive a, the parabola opens upwards. So now we're going to decide which ones open up and which ones open down. So we've got a function, y minus 1/3 x squared equals x minus 3. First, you need to get the function in the form y equals ax squared plus bx plus c. So we need to move this 1/3 x squared over to the other side. So we have y equals 1/3 x squared plus x minus 3. So does the parabola open up or down? Well, it is a positive 1/3, so it opens upward. Okay, because a is equal to a positive 1/3. Okay, so as long as the number is positive, it opens up. So on this one, we've already got everything moved over to the right. We've got a y equals, but we want our ax squared term to come first. So I'm going to switch this around so that I have 3x squared, negative 3x squared plus 5x. And if you notice, our a value is negative 3, so the parabola opens downward. Because, you could just say because a is negative, but we'll say a is negative 3. So if it's negative, it opens down. The highest point or the lowest point on a parabola is called its vertex. So this point right here, whether it opens up or whether it opens down, is called the vertex. If it opens up, that's the minimum point, meaning it's the bottom part of the graph. If it opens downward like this is the maximum. We call it the maximum because it's at the top of the graph. So basically, this kind of gives you the idea of the maximum and minimum. If it opens up like this, we say that the vertex is a minimum. If it opens downward, the vertex is a maximum. It's like the peak of a mountain, okay? So minimum, like the bottom of a valley, maximum, the top of a mountain. Both are called the vertex, though. The vertex is that point of the parabola. So we want to identify the vertex of each parabola and tell if it's a minimum or a maximum. So the vertex on this first one is right here. And if you look, we go over 1, 2, 3, over negative 3 for x. And then for y, it's up 2. So is it a minimum or a maximum? Well, since it opens upward, it's a minimum. And that minimum value is at y equals 2. On this next one, our vertex is over here. We go over 1, 2. So 2 for x. And then up 1, 2, 3, 4, 5. So up 5. And it's a maximum, so it's at like the top of a mountain, and that value is at y equals 5. Unless a specific domain is given, you may assume that the domain of a quadratic is all real numbers. So remember that the domain, we did this a few chapters ago, is your x values. It's another word for the x values of the function. You can find the range by looking at the graph as well. So just remember the range are the y values. So for this graph, y equals x squared minus 4x plus 5, the range, so the y values, begin down here at the minimum, okay? And they go all the way upward forever, okay, because there's arrows. So we would say that it starts at y equals 1 and goes up everything past that. So the y values of the functions are anything greater than or equal to 1. So we can say it as y is greater than or equal to 1, all the y values, all the range. For this one, they want us to tell the domain and the range. So the graph opens down, so we know that we've got a maximum, the peak of a mountain. And the vertex of that peak is, here's the origin, we're going to go over 1, 2, 3, 4, 5. So we go over negative 5 since we went to the left, and down 1, 2, 3. So negative 3. So the maximum is at y equals negative 3. And now we want to find the domain and the range. Well, let's think about this. Domain are all your x values, range is your y values. For your x values, basically x values, if this graph went on forever and ever and ever, it's going to cover all of the x values at some point. It's going to hit all x values. So we just say that it's all real numbers. For the range, though, it's nothing above negative 3, right? It's everything negative 3 and down. So we say y has to be everything less than or equal to negative 3. It's everything below negative 3. So one last problem. Okay, pause, try it, make sure you got it. Identify the vertex. Vertex is right here at the point. Let's see. Here's my origin, so I go over 1, 2, 3, 4, 5. So my vertex is at 5 because I went to the right, positive, and down 1, 2, 3, 4. So negative 4. Does the function have a minimum or maximum? Well, since it's at the peak, this is a maximum, and it's at y equals negative 4. So my domain, since those are my x values, This parabola, because it has arrows, could go on forever and ever and ever, and eventually it would get, I know it's hard to imagine, it would hit, because it keeps getting wider and wider, it would hit all the x values. So all your x values are all real numbers. Your range, however, it doesn't start till down here at -4, so it's everything below -4. So y has to be less than or equal to -4. And we're done.